In this section, we will discuss representation of mathematical functions by using Matplotlib options. First we will consider basic mathematical functions, basic trigonometric functions, sine and cos. Then we will move into the exponential function and logarithmic function, how we can represent all these functions by using this Matplotlib module. And after that, we will discuss one of the special function, which is the Bessel function. The other functions like gamma functions or other functions that you can discuss or you can perform by your own as a homework. Okay. So we will be going through these functions basically. So that you will get a picture of how we can get or how we can visualize these functions by using this matplotlib. So mathematical functions are very important in all fields to represent different kind of variations and properties in a much more effective way. So if you are having a single mathematical function that can be used to study different properties of a system, and visualizing these mathematical functions are very important, which is very important. And that will be useful to understand different system properties more easily and accurately. So in this section, we will be discussing some of those mathematical functions, how we can represent those functions in Python by using this matplotlib module. And we also we will be discussing about Pylab. What is the advantage of Pylab, or how it is different from this NumPy as well as Matplotlib. And also we will discuss in short about this SciPy. Okay. So because we need a SciPy to present the special function, which is nothing but the Bessel function that we will be discussing. So we will directly go to the basic mathematical functions, which are sin x and cos x trigonometric functions. So I will just copy code that I have already written for representing these trigonometric functions, so that you can see that in this window. I hope you can see that. So here we are having this program which is for visualizing the sine and cos functions, sin x and cos x, by using this matplotlib. Let me do this first. I have written this program in ADLE module. That's why it's this. So I will just run it in this platform, online platform, so that you can see both the program as well as output at the same time. Okay, so here in the first step, you are having this import matplotlib, and from that matplotlib you can use this pyplot as PLT. Okay, so you can okay, that's no problem. And then we have this import numpy as empty, because we are using numpy option to get that sine and cos functions. Okay, and you can see that from here, this is our sine function. So we are taking this sine function from that numpy module. That's why we are putting in p dot sine. Okay, similarly cos function also, cosine function also we are taking from this numpy module. And we are also using this arrange function from numpy module. For all those things, we have to import numpy. And also, in order to plot or to visualize these functions, we need this pyplot option from this matplotlib. So we are importing pyplot as PLT. So here I am using plt.plot x comma y1. So this plot will be against y1. So these axes are we have to take this function y1, which is defined as the sine function, and that will be plotted against these x values, and these x values are nothing but these values -1 sorry -11 to +11 with these steps is 0.00. And also we are having the next function, which is the cosine function, which is defined like this, and which is y2, and that y2 also we have to plot against these x values, that is plt dot plot x comma y2. And I have given the label as sine of x here, and here it is cos of x for both of those curves. And then I have given the title of my plot as mathematical function, and give mathematical functions. And then I have given the x label as values of x and y label as values of y, because we are using two different functions, so I cannot give directly sin x and cos x, but instead of that we are uh, I can give values of y, okay, as my y label. And in the legend, I'm having b box to anchor. This is specifying that position of that particular legend that we already discussed in the last class. And then we have also specified the number of columns for that particular legend, which is equal to 1. And then just show that particular plot. Okay, so this is the simplest program that you can have to represent sine function as well as cosine function by using this Matplotlib. So I will be running this program, so you can see here it is running, and you can see the plot. So in this y-axis we are having the label as values of y, and in the x-axis we are having values of x as the x label, and mathematical functions is my title for this particular figure. And I am having this legend sine of x and cos of x, you can see from here. So this blue curve representing the sine of x curve, and this yellow colored one, which is representing the cos x function. Okay, so that's how we can represent the sine and cos. So remember that we can define sine function and cos function by using this method, that is np dot sine of px plus c. And these are optionals. Okay, so this c is optional. You can give c is equal to 0 here, or we can give some space. How much sheet you need, that you can. That is just the starting. It will define this point. So if x is equal to 0, it is just the sign of that value. Okay, so I have given that as 0. You can also give some other values. For example, 2, if I put, then I can run this program, and you can see some changes in the curve. Okay, so you can see now it is at x equal to 0, this will be sine of 2. Okay, and at x equal to 0, this will be cos of 2. So that value will be different. At x equal to 0, the value will be different. Okay, so that's how we can represent the sine and cos function. Okay, and now we'll discuss how we can represent the exponential function, logarithmic function, all those things. So I will just copy the program for that. I have already written the program for that also. I will just erase this. Okay. So I have used here two different log functions and one exponential function. So all these functions are taken to just show you how we can represent these mathematical functions, or how we can use these mathematical functions in different programs, and how we can visualize that. So here also I have imported Matplotlib module, and from that I have imported Pyplot, and I'm having this numpy as np. And here I have given y1. My y1 is my first function, that is log x, that is natural logarithm. Okay, and then I am having np dot log 10x, which is given as the decimal logarithm function, or the common logarithm function, okay, with base 10. Okay, So then we have the third function, which is nothing but the exponential function, exponential of x. So that is also taken from the numpy module. So np dot exponential of x. So this is how we can define logarithm function, natural logarithm function, then the logarithm function with the base 10, and then exponential function in Python. Okay. So in this way, you can define all these functions in any program. Now we will just we also given this x values. Okay, we can see from here arrange 1 to 4 with the subsets of 1 0 0 1. So this much of x values we are having. So we can put all these x values in these functions and plot it against those x values. Okay. All other uh, steps or instructions are known. Here we are plotting this y1 against x, that is, and the label is given as log x, and y2, for y2 we are having log 10x, and then y3 we are having label exponential of x. And now I will just run this, and you can see the corresponding representation, graphical representation of those functions. Okay, so this is how we can represent the log x, log 10x, that is log x with base 10, and then exponential function. Okay, you can see this plot on this side. You can have these different functions, their representation by using this method. So in the same way, you can represent different functions, mathematical functions. I have just used some of the examples. So you can use any other functions, trigonometry functions, as well as any other functions that you can use here in Python, and also you can represent or visualize that by using this Matplotlib. Okay. So another important topic that we have to cover is this PyLab module and how this is different. If you consider this PyLab module, which is another module inside Matplotlib object-oriented plotting library. So if you consider the Matplotlib, which is the whole package, and if you, as we discussed earlier, Matplotlib.Pyplot, okay, that Pyplot is one which is coming inside that Matplotlib, okay, and similar to this, PyLab, if you consider PyLab, that brings classes and functions from this Pyplot. From this Pyplot and also from NumPy. So this PyLab brings classes and functions from Pyplot as well as NumPy and into a global namespace, making them easier to use. Okay, so basically this PyLab use both the functions or the classes in this Pyplot and NumPy, so that we can use if you are defining or if you are importing PyLab, then you don't have to import Matplotlib as well as these, or import Pyplot as well as the NumPy separately. So once you import PyLab, then you can access different functions or classes which is already defined in Pyplot as well as in NumPy. Okay, so we don't have to specify that or import those things again. That is importance of PyLab module. Let us discuss an example here so that you can understand that. So I'm having a very small program for that. So like this. Let's see whether it will work here. Here I'm just plotting x cube, function x cube against these x values, -5 to 5. So I'm using this range of values -5 to 5 and using 50 number of points in between. So that means we are splitting -5 to 5, 50 numbers. Okay, that is what this link space do. Okay. So let's consider this program, and I'm plotting this x, this y, that is nothing but x cube against these x values, and I'm using color as blue and marker as star. Okay, so this is a simple program. So here I have to use the numpy. Actually, I have to import numpy, and then I have to import matplotlib, or from that matplotlib I have to import pyplot as PLT to plot that particular function, right? But that is not required if you are importing pylab. If you are importing pylab, you don't have to import py as well as the pyplot option from this matplotlib. Instead of that, you can just import pylab and you can just plot these functions. Okay, that is the advantage of pylab. Now, if you consider this program and if you run this one, you can just plot that particular function. You can see from this screen, you can see that x cube function with ranging from -5 to 5. So we'll be having in between those -5 and 5, we'll be having 50 number of points, or it will be split like that. Okay, and you can observe that plot. So this is another module pylab, which is also there in Matplotlib option, and it will also use the classes or functions from NumPy module. So we don't have to import that in here. Okay, so this is, I just want to mention that particular module here. And one more module is there, which is called as the SciPy, and SciPy module, which is the SciPy stands for scientific Python. SciPy module. SciPy stands for scientific Python, and which is a scientific computation library that uses NumPy. Okay, in here also it uses NumPy, and it gives more utility functions for optimization states and signal processing. Similar to NumPy, SciPy also an open source library, hence one can use it freely. And also one of the main features of this SciPy module is the SciPy.special package. So that inside that package we are having different number of special functions. SciPy.special package consists of number of special functions of mathematical physics. This includes the elliptic function, Bessel function, gamma function, beta function, all such kind of functions. Okay, and we will be just discussing one of those special function, which is nothing but the Bessel function. And as you know, Bessel functions are a family of solutions to Bessel's differential equation, that is nothing but x square d square y by dx square plus x dy by dx. Let me see whether it is, I can copy that here. That is not coming in the Excel. Okay. Anyway, so this is the Bessel differential equation. You can see that x square d square y by dx square plus x dy by dx plus x square minus v square into y equal to 0. And we will be considering this Bessel function. We will be considering first kind of this Bessel function with real order and complex argument. So in this case, let us consider the Bessel function. So I am not going to discuss all these special functions. You can check the other functions like gamma functions or gamma function or any other special functions that you might be interested, that you can perform yourself. So I will be just showing you the vessel function using this uh, Matplotlib, how we can represent those functions. Okay. So this is the program, and I have used here scipy dot special as sp. So I am using special this special function from the scipy module. Okay, and this special includes all the special functions in mathematical physics, like gamma function, Bessel function, all those kind of functions. So I'm just importing that scipy dot special as sp to get all those special functions, and I will be using here the Bessel function only, and I have also imported this numpy as np because that one I will be using, and this scipy also will be using that numpy module, and then matplotlib.pyplot, and it is used to visualize the Bessel function. Okay, so then I have this much of range for x values 0 to 15, and then I am having so this in between this 0 and 15 I am making this much of points, or that is split, this range is split into 500 parts, and then I am having this for loop for v. So I am taking this Bessel function jv of v comma x, and v is stands for order in this case, and this x is the argument or variable. So here I am using this much of values from 0 to 6. That is the order of Bessel function that I have used, and I am plotting this sp.jv, which is specifying my Bessel function from that special functions inside scipy module. So sp.jv, jv stands for this Bessel function. This part is for Bessel function, and this sp is from this scipy special. So I have imported that as sp. So that's why I'm using sp.jv. jv stands for Bessel function. Okay, so that with order v, so that v is changing from 0 to 6. So I will be having order from 0 to 6. Okay, so all other values are here. So plt x lim, I'm having x values is y that I have specified here. How much values I need for x and for y. So this is not okay. You can also give the end for the entire value. You can take, no problem with that. That only I have taken here also 0 comma 50. Okay, and for y axis also I have limited my values from minus -0.5 to 1.1, that you can change, and then we are having the x label and y label I have given like this, as you can see. Sorry, y label here I'm using like this, and this is, stands for the subscript, and when you are using that you have to use this dollar sign. So this underscore stands for subscript, and here also I'm using legends. So we will be having 6 legends because we are having 6 orders, 6026. So we'll be having 6 number of plots here, and plt dot grid, that will give me the grid lines in my plot. So let me plot this one. Okay, so this is how the Bessel function look like. We have up to J5. Okay, so we are considering this range in this for loop. So it will go up to 5. So we'll be having J0 to J5, total 6, and we are using these labels for these legends. Okay, and you can see this x-axis and y-axis labels also. we are having gen of x in the y axis that we have given here, j underscore n of x, and when you are using subscript of superscript, you have to use this double sign. Okay, so this is the representation of Bessel function in by using this Matplotlib option, and I am we have also used this um, SciPy module to get that Bessel function. For any special function, you can get from this SciPy module. Okay. So other functions like gamma function that you can try by yourself. That is not that much difficult. Similar to this, we have different functions, uh, in this SciPy module. You just have to substitute that in this program and give the respective values, orders, or variables, all those things, and you can plot those things. And I will just copy one more here to show you how we can define those special functions. So this is the syntax that we already discussed here. So this is how we can represent the Bessel function scipy.special.jv of v comma x. Okay. So v is the order and x is the variable or argument. You can consider it as x in this case. You can use any other variable name. Okay. And then we have here you can see the parameters defined here. So V stands for this order, which can be an array-like object, and then we have X. You can see from here we have specified in a range, so we can specify it like that. And then we have the X, which is also array-like, which is nothing but the argument, which can be float or complex value. Okay. Then this particular function j of jb of v comma x that will return this particular function scipy.special.jv that returns the in the array of values, that is nothing but the values corresponding to the Bessel function, and just plot that against x. Okay, so that's what we did here, and you can perform your the other mathematical special functions. Also, you can perform the other mathematical function like tan x or sec x or any hyperbolic functions. All other kind of mathematical functions or special functions that you can perform. So, that is not that much difficult. So I have just given some of the examples. Okay, so the other functions that you can try. Okay. Okay, so that's all about today's class. We will discuss about the interpolation techniques and other